Oh, you mean for the Java to C# stuff? Not yet. That's kind of what we're doing today. I'm like partially. We'll talk about it, but it's not up yet. Okay. So let's pick up where we left off. If you remember last time, we have a scene where our ball can roll one direction, go through the exit, comes out the other thing, gets back to the center, make sure we can't pivot and change directions in the middle, that kind of stuff for our traversal thing. Now, so that's all visual. So this gets back to this. Good. Lost both TVs. Why? Really?
Yes.
Andrew. All right. Well, if they go off again, you'll just have to deal and look up here. All right. So this goes back to this idea of MVC. MVC is our model view controller. That's the design pattern that says, hey, it's a pretty good idea to keep your interface in one place, your controller in another place, so your logic in one place, what your app looks like in another place, and then your data someplace else. So keep all those things separated. So what we've been working on so far is our view, what our game looks like. And then we've had some controllers with these scripts behind the scenes. Well, now we're going to bring data into this in the form of some more code. So if we roll back and we think about how our final state of our Java version of our dungeon, let's throw monsters out of the equation for the moment. We just think about the player traversing the dungeon. We had some code. I'll just go ahead and ignore the errors and stuff like that for right now. We'll talk about all that. Let's see. Yeah, and then we'll fix it. All right. So we had our dungeon that kept track of an array of rooms, yada, 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 what the starting room is, current number of rooms. And then we told it to go ahead and populate the CS department. So it built out a map for us, right? All right. Then we were able to tell our player, go north, go west, go east, and whatever exits there are, right? So at any point in time, our player is somewhere on that map. That map is dictating the rules of the room we're currently in, the data behind the room we're currently in, which exits exist, which exits don't exist. Make sense? So what we want to do here, because of the nature of our Unity application that we've written, is we effectively have a single scene that keeps playing the same room over and over again. Well, we want the attributes rather, of that room to modify based on what room we're actually in. Now, we could try to do this completely programmatically in Unity, just keep track of, a big list of rooms or something like that up in our singleton. But we've already written some logic behind the scenes of something that at the code level knows where our player is supposed to be. And we can ask the current room we're in, which exits should I show and which ones should I not show? Make some sense? So what we're going to do is, if we head north visually, we're going to make our player behind the scenes also head north in our previous code. So at any point in time, what we see in our Unity game and what's actually stored in our code behind the scenes are going to match up to each other, so that we can always ask the dungeon, where am I and what's going on? Make sense? All right. So from an MVC perspective, this will kind of be our model. Model is the data. Okay, so we're going to keep our data in one place. We're going to keep our view in another place, and then we're going to keep our controllers for right now. Let's just say our controller is the stuff that's controlling our guys on the, like our player and that kind of stuff. All right, so what we're doing here is I started off by just dragging. Now, actually, let me just draw a picture real quick that emphasizes what I just said. So we already have our Unity game view. So that's the room with the ball that's rolling around, all that stuff. All right. Now, behind the scenes, we have Unity controllers. Okay, that govern the rigid bodies and things like that that are in our scene. Now what we're going to add is our data from old Java code. We're going to have to convert it to C#, but you're going to see, if you remember when I first introduced C#, I said it's basically Java. You're going to see a lot of the stuff we're going to have to do is like changing capitalized S in string to a lowercase s, things like that, changing slightly the difference between how you extend stuff. Instead of the word extends, you put a colon. You're going to see the syntax is extremely similar. Okay. All right, so we're going to kind of build this sandwich. So if you want to think about this from model view controller, this is our view. This is our controller. And this is our model. You can think of model as just the data. Sometimes that's represented in the database. In our case here, we effectively have something that we would call a data structure called Dungeon that holds the information about the stuff that we want to show on the screen. All right, makes some sense what we're trying to accomplish here? All right, so the first thing we need to do is we need to do some converting of our Java stuff into C#. What I started off by doing is I just renamed all the .java files to .cs files. And what you can do is you can go into your projects on here. And this was our project. You could just download it. So it downloaded that as a folder. There's the folder. I just went in and renamed all the files .cs instead of .java. Okay. And then what I did is I went into Unity. I created a little folder in here just called Dungeon Backend Code or something. That's in my scripts folder. You don't have to do that, but that's what I did. And I just drug all those .cs files in there, which initially is going to create a whole bunch of errors in your Unity project because you currently have a bunch of C# files that have some errors in them because they're written in Java. Okay. So we're going to go and patch these up. And you're going to see that we don't have to do too much patching. Now, what I'm going to do right off the bat is I'm going to get rid of our file for monster. We're not going to have monsters in here initially. And the way we're going to handle monsters is going to be a little bit different. If you want to have a little bit of foreshadowing here, I think I imagine our monster scene to kind of be like the original Final Fantasy game where, you know, when monsters pop up, you go to this new scene and you're in this like back and forth fight situation where you get to choose what your attack is. And, you know, we're writing the controller to govern that. Okay. So we'll get to that next, but let's get some back end stuff where our current goal is we want to have our rooms matching in terms of exits, matching the room that we're actually in. Make sense? So let's get back into our code here. I'm also going to get rid of our worker bee, because really our worker bee dealt with, that was our threads, and that dealt with moving the monsters automatically through our world, right? So that's not going to be part of our initial data here. So we're just going to remove as much stuff as we can that's causing errors so we can fix the other stuff. All right. But now from a data perspective, we're still going to need to know what a room is. We're still going to have a player who knows what room they're currently in. We're actually not going to have a main, but I'm going to leave main in here for now, because really what we're going to do is the stuff that we had in main. Here's our main before, is we created an instance of our dungeon. We told it to populate itself. Then we created our player. We added them to the dungeon, right? Well, what we're going to do is we're going to do this same stuff, but we're going to put it inside of our singleton in our Unity game. Have it go ahead and create an instance of our dungeon, populate it, and slap the player into the current room at the beginning of the dungeon, and then ask the room we're in to update its exits to match that room. Go ahead. Oh, this guy? It's just, man, I just hit the drop down here. It's probably under view somewhere. Okay, so I'm going to go ahead and leave this stuff just for the moment, so that we can ultimately put it into our singleton when we're ready. Okay, because now we're not going to have a main program. Remember, all programs begin and end with main. This is not the Java program or the C# program that's going to dictate our running code. Now we're using the Unity play button effectively, which starts that process off of running all the scripts and things like that, calling the update methods, yada, yada, yada. Okay, so I'm going to leave this here for a second, and we're just going to start going through these. So let's start off with room here, and I've already made some changes in some, so let's just keep going with this. Okay, so notice here that originally this said extends object with a capital O. Now I just changed it to a colon. This is equivalent to extends in Java, and in C#, it's a lowercase o for object instead of a capital O. Now the reality is just like in Java, if you remember, we were using this to introduce inheritance and see that everything inside of Java comes from a top level object. The exact same thing is true in here, I want to make sure I'm recording before I go any further. Yeah, we're good. The exact same is true in C#. So no new lesson there. It's just top level object starts with a lowercase o instead of a capital O. So what we can do here is we can actually just take that off, because room doesn't actually need us to say it extends something. It extends an object, which is what it does by default. All right. Notice here I changed the capital S in string to a lowercase s. Okay, we're going to still have an array of exits. We're going to still have a number of exits. We're still going to have an array of players, even though we wrote this. We wrote it with the idea that we might have more than one player in our game. But right now, we only have one player. We have our current number of players. We decided that right now, we do not have monsters. So I'm going to go ahead and remove monsters from the room. So I'll also remove the current number of monsters. All right, we'll get into our constructor here. Notice again, capital S becomes a lowercase s. What I did right off the bat is I just hit either, for me, it's a Command F, for if you're on a PC, it's a Control F, and do a search for string with a capital S. And then hit the little drop down thing and replace it with string with a lowercase s. Okay, and then hit replace all. Okay, so now we're in our constructor. All this stuff remains the same, but we're going to go ahead and dump our setup for monsters and current number of monsters. We're basically addressing wherever there's red squigglies, because red squigglies means I have a disagreement with the Java code you've previously written. And you're going to see in most of the cases, the changes we have to make are very trivial. Get number of players, functions work the same way. Has exit, notice we do have a little difference here. So we have an exit, we have a direction, but the dot equals method does not exist for strings, because it starts with a capital E. Okay, so major shifts when you go from C# to all right. So now when we take an exit, remember we wrote two versions of take exit. We had a version of take exit that took in a player, and we wrote a version of take exit that took in a monster. And remember, we made that decision independently. Instead of having a collection of inhabitants, so having a single take exit that took in an inhabitant, we made one for monsters, one for players, and we filled up the different arrays. Well, now we've dumped our monster array as well as our number of monsters. So this whole take exit for monsters thing, we can go ahead and just get rid of, because we will no longer have monsters taking exits, at least not for now. Okay. What I'm going to ultimately do here is we're going to add a little bit of randomness for monsters, similar to old school Final Fantasy. How many of you played Final Fantasy, the original one, or maybe even second or third one too? Yeah, the original, or there are all sorts of emulators now. Because the way to power level your guy in the original one is just to wander around in like the woods there, just in circles, until you randomly got into a fight. Because it was always like a coin flip at any point in time, whether you ran into monsters or not. So we're going to do something similar. Like as you're heading towards an exit, monsters might pop up. And then that's going to send you into the death match scene to fight the bad guys and yada, yada, yada. So we're going to do something similar to that in ours, just so we have a little bit of different spin on things. All right. So we don't have the ability to have monsters take exits. We won't need that ability. And we don't have a class for monster anymore either. So that's not going to be, we don't have monsters anyways. All right. Now you're seeing another red squiggly here. This is equals ignore case. There actually isn't one of those in C#. We could just convert it to lowercase and convert direction to lowercase, or we could just say, look, we'll just make it equals. We know we already put in the right kind of directions, north, south, east, west, all lowercase. So we're just comparing two strings there. We're comparing the various strings associated with the direction associated with each exit in this room, and checking to see if that is equal to the direction that we've said the player should take. All right. Now here is another error situation here. So this is how we write something out in Java. To write something out in C#, it's console.writeLine. But that actually is not going to work in here because we have not given ourselves access to the console class, the namespace for the console class. Doesn't matter anyways, because we really want to display something to the screen behind the scenes. But for right now, this was just error checking for us. So I'm just going to go ahead and comment that out. That was just going to go to the console behind the scenes. We would probably end up, instead of giving it the Unity stack, we'd probably end up just using the Unity's logging system for doing that stuff. But unimportant for us, it was error checking that we had in there. All right. So we have all this stuff working here. Remove player from room, Remove monster from room. Monsters no longer exist, so we can dump that. Add monster. Monsters no longer exist, so we can dump that. Add player. We currently have a little error here because setting the current room for a player is not currently working because there's going to be currently errors in player. Yeah, so we haven't fixed up player yet, so it's not going to be happy with that guy. So let's just go and keep going with room. All right, so this guy is going to work itself out once we fix the player class. Here's another output line, another output line, another output line. Again, here's a player. Once we patch up the player class, that error will go away. Calling functions is identical in C# as it is in Java. The whole static versus non-static thing, same stuff in C# as it is in Java. All right, so we won't have to change anything there. Okay, remember, this is our display function when we ask a room to display itself, which actually isn't even a thing anymore, right? We don't ask rooms to display themselves in our thing because our display is our map, you know, or is our what we see on the screen. So really, we can just dump this because we're no longer going to be textually displaying our current room. We're just going to have Unity display it. All right, here's our add exit. And that is going to happen because as we build out our map, we're going to be adding exits to all the rooms, you know. So this was just an output thing. We'll just comment that out. So there's all the changes to room. So now room is legal C# code. We haven't proven that it works yet, but it's legal code. Let's go to exit. So I've already made a couple of things here. The lowercase string, I'll just go ahead and do that same search here. So I'm going to search for capital S string, replace lowercase s string. I may have already done that in there, but I just went ahead and did that. Okay. We go down. Oh, here's something called add monster. Well, we don't need that anymore because we don't have monsters. All right. Well, we're done with exit. All right. Now let's go to player. All right. I'm going to go ahead and get rid of our scanner because we're no longer reading input in from our user. Instead, our user is going to use their arrow keys to drive the player rigid body around our map. And that will give information to our map about what's going on. All right. So we're not going to be asking player, which direction do you want to go? That kind of stuff. So we'll get rid of scanner. We no longer use the word extends. Instead, now we use a colon. That does the inheritance. Technically, we're not even using inheritance really right now because we only have one kind of inhabitant, and that's a player, but let's leave it. We've written everything else. And all right. So, oh, before I forget, let's do a search for string, capital S, replace with string, lowercase, replace all. Okay. Oh, because we haven't fixed inhabitant yet. That's why we have an error here. This isn't a problem. All right. Super still exists in C# just like it does in Java. All right. For play, we're no longer actually playing, right? We're just going to be talking to our dungeon and say, hey, the player just moved to the north, because that's what we can hit the arrow. Update yourself and let me know what the room the player is currently in looks like. What exits do I need to hide? What exits do I need to show? Make sense? So no longer are we going to be having the ability for a player to play. So really, a player is an inhabitant. Nothing more. But we won't go and, let's say, modify it because we already wrote this. And we'll just leave it alone for now. All right, because we want to leverage as much of the stuff that we already wrote as possible, even though we would just have to rename inhabitant to player and move on with life. So if we go into inhabitant here, that's what inhabitant is. We could just call this guy player or copy this, call it player, move on. But just so we see the super work, we'll leave it alone. So let's update inhabitant here. I'm going to go ahead and do a search. Capital S string, replace with lowercase s string. Done. There's inhabitant. And now I expect if we go back to player, this guy's still not cool. Inhabitant has, because I have this set up as private. Must have been one of our examples. We were looking at public, private, protected. So this guy really needs to be protected. In order for children to gain access to it, I'm also going to make that guy protected. And again, public, private, protected, same thing in C# as it is in Java. All right. You're still upset. Why? Well, super does exist. Is this not how you call super's constructor? You know what? Just so we don't waste a bunch of time here, I'm going to do this, copy this, paste it into here. We're going to name this guy player. It's no longer going to be an abstract class. Now we can make these guys private again. We no longer have two different kinds of inhabitants. We now just have one kind of inhabitant, which is a player. So we'll just update our player code to be identical to what inhabitant just was. And then we're going to go ahead and delete inhabitant from our code here. All right, so there's player. I'm guessing I was calling super incorrectly or something. We probably could have debugged it in a couple minutes, but let's move on. All right, so we got room, we got player, we got exit. Let's go to dungeon. All right, so here's our dungeon. We have the ability to add players. We can ask a dungeon to display itself. We're no longer going to do that, right? Yeah, I mean, that's part of that player play. So we'll just get rid of that. And if it pops up error someplace else, we'll clean those up. Set starting room, add room, all that's good. Populate CS department. First things first, no more monsters. All right. All right, it's not happy about room. Let's see, where's my room? We're in dungeon. Oh, hold on. I think the way you create instances in C# might be slightly different. The way you create instances in C#. No. We do have our constructor public, right? Oh, we don't. So inside of my public classroom, I need to make sure that constructor is public. And I'm betting that was the error we had with the inhabitant as well. All right. So constructors typically need to be public. We saw in Java that we didn't actually have to put that there because in Java, the default thing is package level security. And since we had all of the files inside of the same folder, they were all part of what's called the default package in Java, which is why that was not an error in Java. C# doesn't have the idea of packages. It uses something called namespaces instead. So had all these guys been part of the same namespace, we would not have had to make it public. Go ahead. We're probably going to want to make all of our constructors public at some point. I usually like letting it become organic, but yeah, let's go ahead and do that before we run into another error. So I'm just going to do it for the other one. So room, that's public. Exit, that was already public. That's why we didn't have errors. Player was already public. Okay. So there's all my rooms. There's all my exits, yada, yada, yada. Okay, here's where I was placing monsters. We no longer have monsters. We also no longer have threads to control our monsters. So we're just going to dump all that. All right, so we have a dungeon, an exit. All right, so for right now, I'm going to go ahead and I'm just going to take those 4 lines. And what we're going to do is we are going to put those lines inside of, what do we have dungeon set up attached to like the camera or something? Who owns dungeon setup? Player? Nope. Oh, it has to be attached to something. Where was it? Oh, was it? No, it's not there. Oh, yeah. Well, I want to put it in dungeon setup. Well, I don't really want to put it there. I want to put it in my singleton. So where did I call my singleton? Master data. Who do we attach that dude to? Oh, we didn't attach him to anybody. Why didn't we attach him to anybody? Because he's not a model behavior. You can't actually attach him. So we will do this. We can't really do it in room though. Okay, we're going to do this. We're going to write inside of master data. We're going to create a public void setup dungeon. All right. And inside there, we're going to create our instance of dungeon. We're going to populate it. We're going to create our player and we're going to add the player there. Now, then what we're going to do is we're going to have our room call this guy, but we only wanted to update our dungeon the very first time. Make sense? So we're going to have to set a flag in here. So we'll say private static bool is dungeon setup. And this guy will start off as false. And then as soon as we actually set up the dungeon, we'll flip that to true. And then what we'll do in here is we'll say if master data dot is dungeon setup, if that guy is currently equal to false, or you can say if not that guy, but we'll leave it at currently equal to false. That's pretty verbose. So we're only going to set up the dungeon the very first time this guy gets called, because initially his dungeon setup is false. We ask the question, is it currently equal to false? If it is, set it up and flip it to true. Because we only want our dungeon to exist once. All right. Now, we do want to give ourselves access to our dungeon, though. So we're going to go ahead and we're going to say public dungeon CS. Start that guy off at null. And we'll say public player P. Start that guy off at null. And these guys both need to be static. That way we can access it from within our scripts. We want to be able to say, hey, master data, give me the dungeon. I'm going to be updating some movements and stuff like that in there. Okay. And technically, we probably don't need access to the player, but we'll just give it to us just in case. So then in here, don't redefine those guys. And if I want to stay consistent, I usually would throw master data in front of these guys, even though it is not needed here. Anybody remember why it's not needed here? Why did I not need to put master data in front of CS here? Go ahead. Okay. It's a true statement. Actually, technically, I do need it here for a second. Now I don't need it there. So I'm giving you a hint now. Why in this current state do I not need it there? Go ahead.
Because you have to refer to static things from a static context.
Yeah, it was when we talked about the idea of a static context. Inside of this function here, because it's static, that keyword this does not exist. Because we are living inside of a static context. This guy is owned by the class itself. Therefore, he has access to all the other things that are owned by the class. So things in a static context have access to the other things in the static context from the same class. Now, you could either just know that or always refer to the things using, my rule of thumb. If something is static, you access it using the name of the class in which it was defined, right? Even though we didn't technically have to do that here. Same thing's true when you've seen me use this keyword for getting fields and stuff, right? Okay, so this is always right. What you don't want to do, so either do it this way all the time because you know it's always going to be right, or don't put master data in front of it because you understand why you don't need it. Don't do trial and error till red squigglies go away. Okay, that's the thing you don't want to do. All right, so since master data now has a function called setup dungeon that will only set the dungeon up the very first time, now what we can do is inside of our room, we have a dungeon setup script, this guy right here. So as this dungeon is as this room is first coming into existence, the very first thing we're going to do is we're going to say master data dot setup dungeon. And we'll go ahead and do it every single time. But remember, that code is only gonna run the very first time we create a room. Because the very first time we call setup dungeon, it flips is dungeon setup to true. And we only do any of this stuff if it's currently false, which is what it starts off as. Make sense? So we've kind of, again, we've if you've seen the movie The Matrix, right? You know, all systems have rules, and we've played the game within the rules of Unity, and we're like, okay, I know when this gets called. Technically, as of right now, every single time we load our dungeon room scene, a room gets created, the start function will get called every single time. Okay, so this guy will get called every single time we go to the north or go to the west or go to the east. Okay, but I only wanted to actually set up the dungeon one time. So we've had to put in a little booby trap there to make sure it only happened the first time and then kind of turn off that ability moving forward. All right, what's up? Yep. Yep, because effectively, the stuff that used to be in main, go back here, here's main. This is what set up our dungeon. No longer needs to be done because we're now doing it inside of our dungeon setup inside of Unity. So I'll close it here, go over to Unity, and get rid of main. Okay. So now if I run this guy, we should have working code. I have 5,000 errors. Don't you hate that? But it just, in class, it's like, it just worked. Like, I spent 14 hours on this and it did not work. I spent 14 hours millions of times in the past. So it's eventually you'll get to this point. I've already made most of my errors. All right. If you watched, I posted something over the weekend on Slack explaining that angular velocity thing and giving, so if you haven't read that, read what I wrote on Slack. I made a change to the code and I explained why angular velocity works, but I also gave you an alternative, which I think is the more appropriate thing. But read my explanation on there. Okay, so what I'm going to do here is I'll push the code, but let's talk about our next homework assignment. Homework. So I'm going to say given, and I'll post my my GitHub link there. So given that, update the project such that when a player, well, let's say, such that a room always shows the correct exits based on the room the player is currently in. See our new dungeon model from MBC. All right. So you're going to have to ask that guy about the player's current room and find out which exit should I show, which exit should I not show. Allow a player to only go in directions that are legal, which means don't let them roll toward an exit that does not exist. If you've turned off the west exit in the room, that left arrow should not let them roll towards nothingness. Okay? And then make sure to update the dungeon model each time a player leaves a room so that the new room can properly show the correct exits. So effectively, when this is done, you're going to be rolling around the dungeon that is the computer science department, because our rooms will be governed by this new dungeon data structure that we're creating under the hood. That we're always going to be asking, okay, what does the current room look like? Turn off exits, turn on exits, whatever. Okay, what does the next room look like as we move to the north? If I move to the north in this thing really, then I ask the player, hey, tell me about your current room. Same thing, turn on and off those exits. But I've already given you it. You don't need to create any more rooms. You just need to make sure you turn on and off the exits in whatever room your player's currently in. All right, submit your GitHub link and the self-assessment. All right, I'll go ahead and push the current version of my code in case you want to start with that as your starting point. And I will see everybody on Friday. Dated for
I just don't know. I don't know why it's giving me
I put these in as Java files, so I just need to save them and then
save them, yeah, save them externally as .cs, delete the ones you've already done there, and then redrag them in. I did the same thing when I first did it too, thinking I'd be able to rename it inside there.
This is for you unless you're not.
I'll eat it. My wife makes a lot of peanut butter and jelly stuff. Oh, is it? Is there something special about the bread, or it's just bread? Homemade white bread? Okay. Yep, have a good one.